So our last job in section 2.1 is to talk about some algebra techniques that we can use to simplify limits where substitution fails. Notice that if we actually substituted -1 in for x in this expression, we would have a 0 in our denominator. Division by 0 is undefined. We can use a technique similar to what we did when we were computing instantaneous speed, though. So I can say that that's going to equal the limit as x approaches -1 of, notice this numerator factors, that's 2x minus 3 times x plus 1 all over x plus 1. So just a little aside, you will do quite a lot of factoring in calculus. Most of it will be easier than the factoring you just did there. So as long as your factoring is a little bit up to speed, you're going to be okay. But if you want to take a few moments when you have a chance and do some reviewing. So here I can notice that this expression can be simplified. I could have put an equal sign here just as, so that original expression I was given is equivalent to that same limit but of the factored version. So that's going to be equal to the limit as x approaches -1 of 2x minus 3. Notice my divide by 0 problem has been eliminated. I can now evaluate this limit by substituting in -1 for x. And I get -5. A second kind of algebraic manipulation, an algebraic technique you might use to simplify a limit, is called rationalizing the numerator. Perhaps you remember rationalizing a denominator. If you had a radical expression or a complex number in a denominator, you could multiply by the top and bottom of your fraction by the conjugate of that denominator. That would make it so that there was no radical or expression or imaginary number in your denominator. Well, here we want to make the numerator not have any radicals. We will multiply the top and the bottom of our rational expression by the conjugate of the numerator. So in this case, that limit that we've been asked to evaluate is equivalent to the limit as x approaches 16. Notice if I tried to substitute 16 in for x, I'd have my divide by 0 problem. So this is the square root of x minus 4. This is what I'm starting with, x minus 16. It is legal to multiply this fraction by anything that is equivalent to 1. I'm going to multiply top and bottom by square root of x plus 4. Remember, the conjugate of a binomial is the same binomial but with the sign in the middle changed. So if one binomial has an addition sign, its conjugate is the same binomial with a subtraction sign. So square root of x plus 4. Here's the good news. When we do this multiplication, we will have to simplify in the numerator. It's not necessary to simplify in the denominator. So in the denominator, I'm simply going to write x minus 16 times the square root of x plus 4. You could multiply that out. It would take 4 multiplications, but we're going to have to factor it back on the next step. So let's just leave it like it is. In the numerator, I'm going to perform 4 operations to multiply those 2 binomials together. Square root of x times square root of x makes x. Square root of x times 4 minus square root of x times 4. Those terms are opposite, so they'll cancel each other out. That's the whole reason we're multiplying by the conjugate. And then -4 times 4, we're going to have x minus 16. Look at that. I was having a divide by 0 problem, but I have rewritten my expression so that, we'll use red, this x minus 16 and that x minus 16 cancel. So this is going to be the same as the limit as x approaches 16 of 1 divided by square root of x plus 4. Notice when I substitute 16 in for x, 1 over square root of 16 plus 4. 1 over 4 plus 4 makes 1 over 8. Here's one more example. This is about as complicated as the algebra we might do this year, maybe. But here we're going to need a common denominator. What we have here is a complex fraction. It's a fraction that contains fractions. The way to simplify this expression, obviously I won't be able to substitute 0 in for x, I'll have a 0 in my denominator, is to turn this into one single fraction divided by another single fraction, and then I'm going to be able to divide a fraction by multiplying the numerator by the reciprocal of the denominator. So one way to think about this, that's the same as the limit as x goes to 0. I'm going to make this even bigger. 1 over x plus 4. In order to do this, I'm going to need one fraction in the numerator and one fraction in the denominator. My denominator looks like it's already in pretty good shape. So my common denominator up there in the top half of my fraction is going to be 4 times x plus 4. So I'm going to multiply that fraction by 4 over 4. And multiply this by x plus 4 over x plus 4. There's my new expression. That's equal to the limit as x goes to 0 of 4. Try one more time. 4 over x plus 4 times 4 minus x plus 4 over x plus 4 times 4. Remember, this is all still over x. And the good news is, in my numerator, I now have two fractions with the same denominator. So I can subtract my numerators. Limit as x goes to 0 of 4 minus, do not neglect the parentheses here. That would make the most common calculus error, most common algebra error in calculus is failure to distribute a subtraction sign. And you're going to see we do lots of expressions that look like this. That's over my x plus 4 times 4. This is all over x. I'm going to come up here. So if I think about simplifying that subtraction expression, 4 minus the quantity x plus 4, that's 4 minus x minus 4. I have a 4 minus 4 which cancels, leaves me negative x over x plus 4 times 4. And that was all over x. Now I have a complex fraction that looks like one single fraction in the numerator and then expression in the denominator. That x I can think of as x over 1. This is the same as the limit as x goes to 0. Instead of dividing negative x over x plus 4 times 4 by x, I can multiply negative x over x plus 4 times 4 times the reciprocal of x, which is 1 over x. So notice here this x and this x cancel, leaving a negative 1 behind. That's the limit as x goes to 0 of negative 1 over x plus 4 times 4. You can imagine substituting 0 in for x to evaluate that expression. I won't have a divide by 0 problem anymore. I get negative 1 over 16.